The Musician's Guide to Understanding Decibels. Decibels. Ask yourself, how many musicians truly understand what a decibel is? Not many, right? And it's really no surprise. Because the truth is, decibels are confusing. You could read about it in a college textbook for days on end, and not grasp a single useful thing. The good news is though, for audio recording, you only need to know a few basics. And so in today's post, I'll show you the key points about decibels that every musician should know. Hope you find it useful. First off, let's start by dispelling a common myth. Fact: the decibel is not a unit of loudness. It's not a unit of anything. It's a ratio. It compares the value of one number to the value of another. And while those numbers typically measure sound level, it's not always the case. In music, decibels are also used to measure voltage and power in your gear. Next fact: the decibel is not a linear measurement. Most units of measurement are linear. For example, 2 inches are twice as long as 1 inch, and 4 inches are twice as long as 2 inches. If you plotted these numbers on a graph, they would form a straight line. But that's not how it works with decibels. Decibels are logarithmic units of measurement. If you don't remember logarithms from back in high school physics, here is the super simple gist of it. With logarithmic numbers, each additional unit multiplies the true value of the number exponentially. For example, plus 3 decibel equals 2 times the power. Plus 10 decibel equals 10 times the power. Plus 60 decibel equals 1 million times the power. Get the idea? Good. Now here's why you need to know this stuff. How decibels apply to music and sound. In music, decibels are a measurement of sound pressure level, SPL. When we say the speakers at a rock concert are playing at 110 dB, what we really mean is that they are playing at 110 dB SPL. Since the decibel is only a ratio, 110 dB is actually a comparison to a different number, 0 SPL. 0 SPL is the standard air pressure level of the atmosphere, 20 micropascals. It is generally accepted as the lowest threshold of human hearing, and it is the reference point by which all other sounds are compared against. Now, on to some practical stuff. Helpful real-life examples of decibel levels. The easiest way to get a feel for decibels is by measuring real-life noises. So here are some examples of noises we are all deeply familiar with. Breathing sounds, 10 decibel. Whispering, 20 decibel. Normal conversation, 40 decibel. Background noise at a restaurant, 60 decibel. Listening to radio or watching TV, 70 decibel. Garbage disposal, 80 decibel. Jackhammer, 100 decibel. Threshold of pain, 130 decibel. Jet engine, 150 decibel. Simple, right? Good. Let's move on. How decibels alter perceived loudness. To truly grasp the concept of decibels, you need to have an intuitive sense of how a specific change in decibels translates to a perceived change in loudness. I'll be honest. The math here will leave your head spinning. So instead, here are some simple rules of thumb to use as a shortcut. Plus 10 decibel equals 2x the loudness. Plus 20 decibel equals 4x the loudness. Plus 40 decibel equals 16x the loudness. Now here's a word of warning: while these numbers are useful, they aren't perfect. A single decibel level can actually be heard at multiple levels of loudness. Here is how. How frequency balance affects loudness. When you think of 60 dB SPL, you would imagine it being attached to one specific level of loudness. Turns out that's not true. The level of loudness our brains perceive also depends on the frequencies contained within the sound. At equal decibel levels, mid-range frequencies, those between around 1 kHz and 4 kHz, are perceived as sounding louder than those frequencies in the low and high bands. This phenomenon can be explored further in a chart known as the Fletcher-Munson curve. Okay, next point. How distance affects loudness. It's common sense. The farther you move away from the sound source, the softer the sound gets. What's less obvious is, by how much? Again, the math is complicated. So here are two rules of thumb to keep things simple. 2x the distance equals -6 decibel. 10x the distance equals -20 decibel. Now that you have an intuitive understanding of how decibels measure sound level, there's just one more thing you need to know. How decibels are used in recording equipment. The most common place you see decibels used in the recording studio is with the level meters, which can be found on many devices in your studio such as your DAW, audio interface, and more. At the top of a level meter, you notice a marking of 0 dBFS, meaning 0 dB full scale. This is the highest possible signal level the equipment can accommodate before clipping or distorting. Below that, you see ever-increasing negative values of dBFS, all the way down dBFS. Depending on who you ask, people will tell you to aim for anywhere between -15 decibel and -6 decibel when setting input levels for recording. I find -10 decibel to be a good compromise.